nobody even looked. Okay. So then let me give you a couple of hints. So the first thing is, it is very clear that you can recognize who's here and who's not here. So anybody who was here knew that if you take a hair and you want to look inside, you put it in an index matching fluid, and therefore you can do it. Some people just took the hair apart and sliced it open, and I don't know if they tried to eat it, but I mean, obviously that person wasn't here, right? So not everything we do is that primitive. The other thing I had lots of fun with what is this here? Oh, when did you see a virtual image of yourself last? I mean, obviously you are not thinking and looking at a mirror at the same time. Because when you start really, all what happens is, that there's me and you look at the hair, right. Let me tell you, next time you go on the front of a mirror, go put your clock on it and look at the clock in the mirror. The clock is wrong. The clock goes counterclockwise. I mean, how stupid. You need another clock, right? So you also find out that 3 o'clock is not here, 3 o'clock is here. And all that you haven't learned yet. So I'm very happy I asked this dumb question, right? Not about virtual, but how to totally change the geometry in a mirror. The big physicists know that because it's a space transformation. And so we knew that when we coordinate chopping with it. But that one I thought was really okay. So now I know this is you. So look at your test. It's not alphabetical. And after you have seen it, put it back in the pile and give it back to me because we have not registered. Okay. So this first one was the hair. The next one is the magnifying glass. So most of it got that much that you have to have focal points. Actually, again, those which were here make focal points. The other ones have lost it. And then here is the object, and you look for that thing. Right? And there is the magnification. So, however, that was only half the question. The other half of the question is including your eye. So now some people have very funny eyes. They have eyes like that. I mean, none of you have eyes like that as I see. They look quite different. And we have even thought about the eye, right? This has another lens. It's full of water called the humor. And it has another. So there's another lens, and then finally you get an image. 2 of you got that. The rest just simply, this is not an eye. Let me tell you that, all right? Next. How do a musician heal glass? I mean, that obviously, those who were here knew the answer, those who didn't hear would take that answer. That was the one they dropped. Right? So do you see how valuable it is to come to class? Good. You're supposed to laugh sometimes. Okay. So then the Galilean thermometer, again, most of the people who were here and they saw that thing and we talked about it, recognized that this damn particle changed their behavior in the glass tube because the water expands. expands when the temperature changes. Not the glass. The glass expands too, but thousands of the water. Right? So what happened is, so everything is done by the water, and so that sets this up and down. And how do we know the whole universe is made of and the atoms in the Milky Way? I sort of give you a hint, but I think only about one of you answered that question, because that's the easiest question of all. I think, I hope, maybe I'm already too old to forget things. We talked about a gentleman called Fraunhofer. Mr. Fraunhofer was a prototype of a gentleman as you should follow his track. He was born terribly poor. His mom died at birth. Then he was given to his uncle, and the uncle died 4 months later. And then he finally ended up in a monastery as a child without parents. And in this monastery, he's a monks. The monks found out he's very smart, right? And at that time, this was about 1800. They would have liked to know if God hasn't written their future into the stars. But the stars are all up there, and so the question is, was there a recipe down there, up there for me, to say if I come back to heaven, if I be a bad boy, what I have to do to redeem myself, and so on and so on. And so they gave him lots of money. So he built the best telescope which was around at that time in the whole world. America wasn't very involved in science yet, but in England and in France. And and now they wanted this guy, wanted to hire him. And the monks kept them and kept them and kept them, until one day he looked in his spectrum of the sun, and this was, what you hear the colors. In between were black lines. In very irregular distance. Some stronger, some weaker. And he figured out that when the light, wherever it's made, and comes to you, it has to go through me. Right? You say, oh, between the sun and us is nothing. Sure there is. There's a halo on the sun, and there is the atmosphere in our world. So the light had to go through the halo of the sun, and the light had to go through the atmosphere of the earth. And what happened is, these lines, which are nowadays called Fraunhofer lines, are there to find out. And then we found out, he found this already, that by looking at Jupiter, that had the same spectrum. And then he found and looked out into galaxies, into the Milky Way. And wherever he looked, they looked alike. So that means you are made from stardust. You are made from everybody is equal. That's what physicists like. Everybody is equal. When we became obviously mentally, there are books written about it and everything. So what I wanted to know, because I told you here, what are Fraunhofer lines, which proves that the atoms are the same everywhere. All right. Now, as for the brownie points, I think 95% A answered them, and B made 10 points. So because it was easy to go, and so that one there was. Let me ask you about this question. Can you say isotope is a gas chromatograph? Come on, you You've seen that, certainly. Compared to what you can do in a gas chromatograph, you can separate proteins and enzymes, which are chunks, compared little isotopes, one at a time. The problem is why we don't do it by the bucket is because it's so slow. So you have to wait so long before you had a gram, right? And so therefore, this is only done for the most various sensitive isotopes, but it's done. For instance, if you go to the hospital and you get tested with iodine 151, what the hell do they get that from? Well, they get it because it is in iodine by a certain percentage. You can sort it out, you can give it to you, and it falls apart. It has a relatively short life. Okay, so next. Do you have any questions so far? Not yet. Don't ask me about individual questions, general questions. Because this one will now be going back to the guy. If you see, I made an error. Just look how many numbers I had here. So yes, a big errors. And so if I make an error, tell me. Then we make it right from the beginning. And if not, then I can go on and start a brand new area of science. Because you see, this is forensic science. And the most important part in forensics is either doing things. I mean, the question is, why the hell did I uncover a problem with a nice little gadget with balls pedaling in there? What does that have to do with forensic science, right? But remember, there was that guy who was condemned to death because he had sand in his cufflinks and he had killed the lady and cut the head. I hope you remember that. That was actually the first time in scientific forensic science that this was done. But today, this is done constantly. When there are murder cases, when there are, you go in and use these techniques. Or for instance, I was involved lately again in a glass case, right? Where I had to show that this glass was from this headlight. And so what I did is I got myself headlights and I measured the glass in the oil and see what kind of and what happened is in this oil. Let's assume you put one in a shot. The terrible part is, you cannot do all this with a piece of nice polished window glass. Nobody delivered that. This damn thing looks like this, right? And then the water goes all around it, and then suddenly it vanishes. So what happened is, you don't know what a glass it is. You throw it in. It looks, yes, it's a little bit harder to see, but not to convince the jury to kill somebody for it, right? So what we do is this resin oil, which you have seen, which I demonstrate for you, right? You put a fire underneath it, not a real fire, right? A heater, and then you will find out that the index of refraction of that oil has a strong temperature dependence, right? And so you can measure how this thing vanishes in front of your eyes as you put heat underneath it. Well, you say, well, but then how do I know that? How much that is? The question is, we can calibrate this glass and buy yourself from the companies like Schott and others, which make glass. They make glass for microscopes. They make glass for all this kind of stuff, and so we can calibrate it with a well-known glass. Make this experiment until this is equal, and then we know what the case is. And so as far as my experience is so far is, I never had trouble, even went already to corn.